Dear students, in this session we are going to see about the Gauss divergence theorem. First, let us see the statement of the theorem. Let E be a simple solid region and S is the boundary surface of E, given with the positive orientation, that is outward orientation. Let F be a vector field whose component functions have continuous partial derivatives on an open region that contains E. That is, if you consider this as the electric flux, then the divergence theorem states that the surface integral of any vector, that is the F vector, around a closed surface is equal to volume integral of divergence of the same vector around the region, is called as statement of the divergence theorem. Therefore, surface integral of f dot ds is equal to volume integral, that is triple integral of divergence of f dv. Divergence of f means del dot f, it is a dot product, so del dot f dv. So it is a statement of the divergence theorem. Surface integral of f dot ds is equal to volume integral of divergence of f dv. Let us see the proof of the theorem. We must show surface integral of pi plus qj plus rk dot n cap ds is equal to triple integral, that is volume integral of del dot dv. Del means the operator called dou by dou x plus dou by dou y plus dou by dou z of I vector plus j vector plus k vector. That is dou by dou x of I vector plus dou by dou y of j vector plus dou by dou z of k vector is the operator called del. So del dot f is equal to dou p by dou x plus dou q by dou y plus dou r by dou ez into dv. It suffixed to show that surface integral of p I vector dot n cap ds is equal to triple integral of dou p by dou x dv. Similarly for qj and rk. So we will show the last. Let us consider others are similar. Assume E is a region of type 1. Then E of x comma y comma z in the area of x comma y is given by upper limit of u1 of x comma y and the lower limit of u2 of x comma y for the region z. Similarly for x and y. Then the rk dot n cap ds, surface integral of rk dot n cap ds is given by surface integral of r of x comma y. For the z we have to give the u2 of x comma y limit into dA. Therefore, for the S1 in the outward normal points down, so surface integral of rk dot n cap ds is equal to minus of surface integral of r of x comma y comma u1 of x comma y dA. Before that, for the upper limit u2 of x comma y and for the lower limit u1 of x comma y minus of u1 of x comma y dA, since it is lower limit. Finally, on S3, that is n dot k is equal to 0. For S3 surface, r of n cap ds is equal to 0. Putting it all together, that is surface 1, surface 2 and surface 3, we are getting the value of final value, that is surface integral of rk dot n cap ds is given by r of x comma y of u2 of x comma y, that is the upper limit, minus r of x comma y u1 of x comma y dA, that is the lower limit. Therefore, surface integral plus line integral of u1 of x comma y, u2 of x comma y, that is the lower limit is u1 of x comma y and the upper limit is u2 of x comma y, dou r by dou ez dez dA is given by the answer dou r by dou ez dv. Similarly for the vectors pi and qj. For pi vector the answer is given by dou r, that is dou p by dou x into dv. For q vector dou q by dou y into dv. So putting all together we will get the answer as surface integral of f dot divergence of f dot n cap ds. So we can prove the theorem. Thank you.
Let us see an example for the divergence theorem. See the closed surface S in which electric flux is flowing. So we have to find the value of divergence of this surface. So we have to find the divergence of this surface by using surface integral of f dot n cap ds. By using divergence theorem, that is equal to volume integral of divergence of f dv. Here dv denotes that dx, dy, dz. There are three coordinates x, y, z. So dv denotes dx, dy, dz. Therefore, the surface integral of f dot n cap ds in a closed surface is equal to volume integral of divergence of the same vector F around the volume. Let us consider the surface shown in the figure. It has the coordinates x of 1, 0, 0, y of 0, 2, 0, and z of 0, 0, 1. And the surface is z equal to 1 minus x. And the value of f is given by xy I vector, y z j vector, z x k vector. The I vector, j vector, and k vector are not denoted, but it represents I vector, j vector, and k vector. We could do this with 5 surface integrals. We have to do 5 surface integral for this surface. But in order to reduce the surface integral, we are going for the volume integral with divergence. So divergence theorem is used to found the divergence of a vector field around a closed surface. So instead of going for the surface integral, we are going for the volume integral. Divergence of f. What is meant by divergence of f? We already know divergence of f means del dot f. Del is the operator which is called as dou by dou x I vector, dou by dou y j vector, plus dou by dou z k vector. So now the del dot f, that is divergence of f, is given by dou by dou x of xy, that is equal to y, plus dou by dou y of yz, that is equal to z, and dou by dou z of zx, that is equal to x. So we need our bounds of integration. We need for the limits of the integration, the upper limits and lower limits, which is given by the coordinates. For the z, the coordinates are 0 to 1 minus x. The f is given by, del dot f is given by y plus z plus x. So first we have to integrate with respect to z, then y limit is 0 to 2 and the x limit is 0 to 1. So first we have to integrate with respect to 0 to 1 minus x, y plus z plus x dz. Then we will go for the dy, then we will go for the dx. So first one is 0 to 1 minus x, y plus z plus x dz. The answer is yz plus z squared by 2 plus xz. The lower limit is 0 and the upper limit is 1 minus x. So if you substitute the limit, we will get the answer as 1 minus x of y plus 1 minus x by 2 plus x. Z is replaced by 1 minus x. And the lower limit is 0, so that will be negligible. So it is the answer for the z integral. That is the line integral of z with respect to z. Next we have to go for the y integral with respect to y. So the answer is 1 minus x into y squared plus 2 plus xy by 2 plus y by 2. The limits are 0 to 2. So we have to apply the limit. If you apply the limit, we will get the answer as 1 minus x into 2 plus x plus 1. Now we are going to give the surface integral for the 0 to 1. Give the line integral for the 0 to 1. For the answer 3 minus 2x minus x squared dx. The answer is 3x minus x squared minus x cubed by 3. And the upper limit is 1, lower limit is 0. We have to apply the limits. The answer is given by 3 minus 1 minus 1 by 3. That is equal to 5 by 3. So which is given by the answer surface integral of f dot n cap ds. So instead of going for the surface integral, we will go for the volume integral. But this theorem has applicable for Gauss law. It is also used for the Gauss law. In a closed surface, the flux of an electric field is equal to surface integral of d dot n cap ds. That is equal to amount of charge contained within the volume. That is volume integral of rho v dot dv. Thank you.